Imagine you have a benzene ring and you want to attach a single aldehyde group to it, turning a simple hydrocarbon into something as fragrant as benzaldehyde, the scent of bitter almonds. Usually, you'd reach for the Reimer-Tiemann reaction or a Friedel-Crafts acylation. But there's a more elegant, direct way to do this using nothing but hydrogen cyanide and hydrochloric acid. This is the Gattermann reaction. Let's look at the starting point. We have our benzene ring, stable and unreactive. On the other side, we have a mixture of hydrogen cyanide, or HCN, and hydrogen chloride, HCl. At first glance, these two don't seem like they could do much to a benzene ring. But notice what happens when they meet. The HCl acts as an activator. It protonates the nitrogen of the HCN, making the carbon atom incredibly hungry for electrons. It becomes a potent electrophile. And the presence of a Lewis acid catalyst, like aluminum chloride, which we see here acting as a molecular crowbar, this complex becomes reactive enough to actually break into the benzene ring's sturdy pi cloud. Watch what happens as the benzene ring attacks this activated carbon. The hexagonal symmetry breaks momentarily, creating what we call a sigma complex. This is a high-energy, unstable state. But chemistry loves stability, so a proton is quickly kicked off and the aromaticity of the ring is restored. As you can see on the screen, we haven't reached our aldehyde yet. Instead, we've formed an intermediate called an aldamine. Notice the carbon-nitrogen double bond. This structure is the skeleton of our final product, but it's still holding on to that nitrogen atom. Here's the key insight. The transformation isn't finished until we introduce water. During the final step, acid hydrolysis, the water molecules act like a pair of chemical scissors. They attack the carbon-nitrogen bond, snipping away the nitrogen and replacing it with oxygen. Notice how the nitrogen leaves the scene as an ammonium ion, and suddenly our benzene ring is topped with that characteristic C double bond O and hydrogen. We've successfully formulated the ring. But wait, why use this instead of other methods? The genius of the Gattermann reaction lies in its precision. While Friedel-Crafts often requires bulky acid chlorides, Gattermann allows us to build the aldehyde group in situ using simpler gases. It's a surgical strike on the benzene ring. So, the next time you see an aldehyde group attached to an aromatic ring, remember this sequence. Activate the cyanide, let the benzene attack, and let water finish the job. It's a beautiful reminder that in chemistry, even the most stable structures can be transformed if you have the right tools to bridge the gap.